Alright, so today we're going to take the angles that we've been talking about in standard position and we're going to start talking about ratios that we can create from triangles on those angles. So a radius vector is just the distance from the origin to some point out here on the terminal side of an angle. And so on this vector, I'm going to name this point out here just x comma y. All right, r just represents the distance that I've gone out, and since it is a distance, r is always positive. R is always positive. So remember that forever. R is positive. It's a radius. Just think of it as a radius of a circle, the distance. Okay. So if I named this point xy, then I'm going to draw a little dotted line down here to the x-axis, perpendicular to the x-axis, and form a little triangle. Well, to get to this point out here where this touches my x-axis, I would have to go out this x amount. This distance would be x, and to get up there to that point, I'd have to go up y. So out to the right x amount, up y amount, and so on my triangle I end up with these letters, x representing the distance across the x-axis, y the distance up the y-axis, and then r the distance out from the origin on my circle. Well, we can do comparisons of all of these measurements, x, y, and r. So the ratios of y over r and x over r and y over x, it doesn't matter where I put that point. I could have put it out here because we learned back in geometry that all of these right triangles would be similar to each other. So it doesn't really matter. The ratio would stay the same, even if the numbers change. So if that's true, if these ratios are always the same, then we can give them all a name. And that's really all the trig functions are the names of these ratios or comparisons. So here are your trig functions. The sine is a comparison of y over r, the ratio of y over r. Cosine is x over r. Tangent is y over x. And these are called the reciprocal trig functions because if you look, cosecant is the reciprocal of sine, y over r, r over y. Secant is the reciprocal for cosine, r over x. Cotangent, the reciprocal for tangent, x over y. And so we're going to be using these ratios so often that this is going to become second nature, but you have to memorize these ratios. So memorize these ratios. And I do want to write out here, this looks like sin, cos, tan. It is not. It's actually an abbreviation for S-I-N-E, sine, C-O-S-I-N-E, cosine, tangent, T-A-N-G-E-N-T, cosecant, secant, and cotangent. And those are just the names for these ratios. Alright, so we're going to actually put some numbers to some pictures so that we can find ratios for these trig functions. So they're giving us a point, 6, 8. So we're going to go out 6 and up 8. We're going to draw our point, and then we'll draw that radius vector through the point. And then I'm going to draw down to the x-axis and make my right triangle. And I know that this is 6 units, and I know I went up 8 units. And in order to do my trig function values, I'm going to need to find this r value. We've created our angle, but we don't know the length of our radius vector. So we're just going to use Pythagorean theorem. 6 squared plus 8 squared has to equal r squared. So 36 plus 64 is r squared. That's 100 is r squared. So r would be 10. And remember, r is always positive. So we're going to go through all of our trig ratios. So sine, remember that sine, I'm going to write it over here as y over r. So y is 8, r is 10, so we get 8 over 10, which reduces to 4 over 5. The cosine ratio, cosine is x over r, so we get 6 over 10, which reduces to 3 over 5. And then we have our tangent, and tangent is y over x, so 8 over 6, which reduces to 4/3. So those are our sine, cosine, and tangent ratios, and if you have those, then these others are really easy. The cosecant is our reciprocal, so just remember sine and cosecant kind of go together. It would be 5 over 4. The secant, 5 over 3. And the cotangent, 3 over 4. Those are the exact values of our 6 trig functions for this triangle. All right, let's do the same thing for the next one. We have -4, +2. We have our radius vector. All right, draw down to the x-axis. We have a little triangle here. We know that this is -4. We went up 2, and we still need to find that radius vector. So we have x squared plus y squared equals r squared. Now, this is negative, but when we square it, it becomes positive 16 plus 4. So that's 20. And we are not going to use decimals, so we need to reduce this. So we're going to reduce this down by finding all of our factors, because we need to pull out any of our double factors here when we take the square root. So 20 is 2 times 10, 10 is 2 times 5. So 2 times 2 times 5 is 20. For the pair of 2's, I can take out a 2, and then I have to leave in the 5. So r is 2 square root of 5. So you have to simplify this. You can't use the decimal. You have to simplify it. So go over and find the factors. The doubles come out. The singles have to go back under the root. All right, so now we just set up our trig ratios. So sine is y over r. So we have 2 over 2 square root of 5, or just 1 over square root of 5. Now we're going to come back to that because we're really not supposed to leave roots in the denominator, but I'll come back to it. For cosine we have x over r, so -4 over 2 square root of 5 would be -2 over square root of 5. And then for the tangent, we have y over x, so 2 over -4, which is -1/2. Okay, for the cosecant, we just flip this over, so it would be the square root of 5 over 1, or just square root of 5. Secant, we're going to flip it over, square root of 5 over -2, and cotangent. So 2 over -1, or just -2. All right. So for these trig ratios that have square roots in the denominator, we are not supposed to leave them. So in order to get a root out of the denominator, you multiply both numerator and denominator by that root. So let me show you what I'm talking about. Here we've got 1 over square root of 5. I'm going to multiply that by square root of 5 over square root of 5, which gives me the square root of 5 over the square root of 25. And the square root of 25 is 5. So this is equivalent to square root of 5 over 5. Both of these are equivalent to each other. This one is the proper answer. This one is not supposed to be left alone. So we do the same thing here. If we multiply by square root of 5 over square root of 5, we'd have negative 2 square root of 5 over 5. And this would be the proper answer. All right. So just one additional little step, but overall what we're doing here is just using those trig ratios to set up the comparison. Y over R, X over R, Y over X, and then the reciprocals of those. All right, so we know that our angles can fall in any of these quadrants. So remember, this one is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And in each of those quadrants, if I were to draw in a triangle, always drawing back to the x-axis, then the value going out this way is always going to be a positive x value. A value going up here would be a positive y value, and r is always positive. In this triangle over here, this value would be a negative x value, positive y, positive r. In this triangle down here, I would have negative x, negative y, and positive r. And in this triangle, I've got positive x, negative y, and positive r. So with those in mind, with those positives and negatives in mind, we can kind of look at all of these ratios. In quadrant 1, x, y, and r are all positive. So it doesn't matter which one I do, x over r, y over r, y over x. Everything, all trig functions are positive in this quadrant. But in this quadrant, in quadrant 2, anything that has to do with x, it's going to be negative. So if you'll look back at your ratios, cosine is x over r. So cosine is going to be negative. Tangent is y over x. Tangent is going to be negative. So the only trig function that would be positive in this quadrant is the one that has to do with y and r, and that would be the sine ratio, and of course its reciprocal cosecant. And then down here in this quadrant, anything that has to do with x is going to be negative. Anything that has to do with y over r is going to be negative. But if I were to combine like the y over x or the x over y, that would be positive, and so tangent ends up being positive, and its reciprocal cotangent. And over here, it's the y that's negative, so the only one that's going to be positive here is the x over r, which is our cosine ratio, and its reciprocal secant. So there's a little acronym that might help you with this. It says all students take classes. All students take classes stands for all are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So maybe that will help you out some too. All students take classes. Okay, so once we have all of this in mind, they have some questions for us over here so that we can try to get this straight in our heads. So they want to know, in which quadrants would cosine and tangent be the same sign? That means either they're both positive or they're both negative. Okay, well, they're both positive in quadrant 1, right? So quadrant 1. But then let's talk about where they're negative. Where would they both be negative? Well, cosine is positive here, and tangent is positive here. In quadrant 2, sine is positive, but that makes the other trig functions, cosine and tangent, negative. So in quadrant 2, they're both negative. So you have to think about these. All right, number 4 says, cosine is negative and sine is positive. Cosine is negative, sine is positive. Well, sine is positive here, and cosine would be negative, so this would be in quadrant 2. All right, cotangent and secant have opposite signs. That means one is positive and one is negative. So remember that cotangent is kind of like tangent. It's a reciprocal of tangent. Secant, like cosine. So the same question could have been asked of tangent and cosine. Where are they opposites? Well, everything's positive in quadrant 1, so they're not opposites there. In quadrant 2, tangent or cotangent would be negative, but so would cosine, so they're not opposites there. In quadrant 4, tangent is positive, but cosine would be negative. So in quadrant 3, and also in quadrant 4, where cosine is positive, tangent is negative. So on your homework, there are going to be some questions like this, where you're going to have to think about which quadrant would they be positive or negative in. All right, so given a point, you should be able to give me all 6 trig ratios, and then this hopefully will be helpful in answering some of these questions.